Hello everyone. Now we are going to talk about the questions in acid-base titration. So let's have a look at these questions. So we have a NaOH solution. It is titrated to be this concentration. And after exposed in air for some time, it absorbs CO2, carbon dioxide. Then 0.1143 mole per liter hydrochloric acid is used to titrate this 25 milliliter sodium hydroxide, and 22.31 milliliter is used when using pp as indicator. So how many grams of carbon dioxide is absorbed by 1 liter NaOH? So before we calculate the grams of CO2, first we look at this part. NaOH, after it is exposed in air for some time, it absorbs CO2. What reaction is it? When sodium hydroxide absorbs CO2, what's the reaction? And what's the product?
There are two products, teacher.
There are two products.
That's possible.
Possible.
Yeah. The one is Na2CO3 and other one is NaHCO3.
NaHCO3. Another is Na2CO3.
Yeah.
Right, which means NaOH plus CO2. What's the product, right? Just now you said NaHCO3 and Na2CO3. So now let's continue to look at these two products. NaOH and CO3. Two products, NaHCO3 and Na2CO3. So in this system, are these two products possible to exist? This one and this one. NaHCO3 and Na2CO3. So if NaOH and CO2 have the reaction, then the product, there are two products, right? Which of them are possible to exist? Which of them cannot? Or both of them can exist?
NaOH can react with Na2CO3, but it cannot react with NaHCO3.
Na2CO3.
Yeah.
You mean Na2CO3 is a product of this reaction?
Yeah, teacher.
Then why not this?
I think NaHCO3 will be the product of NaOH.
NaHCO3 will be the product of this?
Yes.
And one is this one. One answer is this. Another answer is this one. What do you think, other guys?
I think Na2CO3 is the product.
This one is right. So this one is right because NaHCO3 will continue to react with NaOH to get this product.
Yeah.
Which means NaOH, when NaOH absorbs CO2 in the air, the product will be this one, Na2CO3. Okay, so first we are clear about this thing. So when NaOH absorbs CO2, in NaOH solution, there will be part of first is NaOH. Another is Na2CO3. Right? That's the NaOH solution after it absorbs CO2. Okay, one is NaOH, another is Na2CO3. And then we do what? And then we use HCl to titrate this NaOH. And this volume is used when using pp as indicator. So first, if this NaOH doesn't absorb CO2, when we use HCl to titrate NaOH, what's the amount ratio between HCl and NaOH?
1:1.
Yes, it's very easy, right? Acid and base reaction, 1:1 should be the ratio of HCl to NaOH. And is it 1:1 in this question?
No.
We can do a little calculation. Use here the concentration of HCl and the volume it used. If we do a little calculation, we can find out 0.1143 times 22.31 doesn't equal to 0.1026 times 25. And the result is what? I'll tell you the result. The amount of HCl will be smaller than the amount of NaOH, which means this one times this one. And why? Why the amount of NaOH is larger than the amount of HCl? Why? Usually, if NaOH doesn't have other reaction, HCl and NaOH should be the same, right? But now they are not the same. The amount of NaOH is larger than the amount of HCl. It is because of what?
Because it absorbs CO2.
Yes, it absorbs CO2 because NaOH has some reaction, right? And why NaOH becomes Na2CO3 makes the smaller amount of HCl. Now we are going to have a look. So just now we know that the reaction is what? The reaction is NaOH plus CO2 will become Na2CO3, right? And we know that here 2 sodium, then here we'll add 2 here, right? And what? And we also need to have a water, right? So you can see that to get 1 Na2CO3, we need to have 2 NaOH, right? And then when we use HCl to titrate, we can get what? Remember, we use pp as indicator. So when we use pp as indicator, HCl and sodium carbonate will get what? We'll get
Sodium
We
chloride.
get
We get sodium chloride.
louder, please.
Sodium chloride. Sodium chloride.
Sodium
chlorine,
NaCO3.
NaCl.
CRDM.
AACl
Yeah.
Plus
plus
A2C. A2.
AA
HCO3.
HCO3, right? So you can see the ratio between NaOH and HCl. We can get here 1 and 1, which means HCl here 1 NaCO3. Here HCl and Na2CO3 is 1, 2, 1. And Na2CO3 with NaOH is what?
1, 2, 2.
1, 2.
2 NaOH, right?
Yes.
Which is 1, 2, 1, 2, 2. Which means 1 HCl will take 2 NaOH, right? But in common condition, this should be 1, 2, 1, right? But in this situation, 1 HCl can titrate 2 NaOH. And that's why we use smaller amount of HCl, right? Usually, the ratio is 1 to 1. But here, it is 1 to 2. So,
1, 2.
the used HCl becomes smaller. And the difference, you can see 2 to 1. And the difference is what? The difference between these two amounts will come from what? Will be the same to what? Due to what?
CO2.
The difference of the amount. The used HCl and the amount of HCl in theory. The difference will be the amount of CO2. Okay, are we clear here? A little confused.
Teacher, can you explain about the CO2 again?
Yes, here you can see what 1 to 1 and 1 to 2, right?
Yeah.
And we have the difference. We have the difference of the used amount and the theory amount, right? So the difference 1 to 2 and 1 to 1. The difference is what? 2 minus 1. It equals to 1, right?
Yeah.
This 1 is the one from here, right?
Right.
And this 1 equals what? Here is also 1. Here is also 1. 1, 2, 1. Which means this 1 is the amount of Na2CO3, but also the amount of CO2. That's why from the difference, we can get the amount of CO2. Okay? So since we know the amount, then can we calculate the gram?
Yeah,
Yes.
we can.
So let me write it here. M. Okay, what's wrong? M equals to what?
And
M equals to
And
N. This is the amount, right?
yes.
Then multiplies
And
molecular weight, right? We
yes.
will use different M. And this is the idea how to solve this question. And let's have a look at the answers. Okay, this is how we get the final grams of carbon dioxide. Because we said how many grams per liter. We can also use this gram per liter. It's also a unit of concentration. Or if we can directly take it as weight. In 1 liter, it's a weight. Okay? So this is how we solve this question. And that's all.